E-commerce students, good day. Today we are going to be getting into the actual backbone of what makes e-commerce work. If you have never had a reason to explore how the internet actually works, today is your day. It seems like magic sometimes, but in reality there's a lot of moving parts behind the scenes. And this is really to give you some legacy in terms of knowing how the internet actually empowers what happens with e-commerce. So buckle up and keep your hands inside the ride until it comes to a complete stop. So we're going to be talking about where the internet came from and where all these powerful technologies that make it work came from and how they empower electronic commerce. We're going to be moving at a pretty good clip today. There's a lot of history to talk about, a lot of concepts to talk about. By the time it's done, you're going to know just how miraculous it is that e-commerce works the way it does. So what is the internet? People sometimes think that the internet and the World Wide Web are the same thing. They're not. The internet is the actual network that connects all of us on this great big shared connected network. It's what we refer to as a self-healing network. And so the internet started in the 1960s as a Department of Defense project here in the United States. And the purpose for this internet was to have a means of communicating in case of atomic attack. It's called a self-healing network, meaning that if one leg of the network goes down, traffic will get routed to other places. And if you've never really thought about what a network is, a network simply is a way to move data between locations. And so in the old days, networks were what we refer to as point-to-point. The internet was the idea of a large, flexible network that could connect lots of people for communications regardless of a leg of the internet dropping off. The World Wide Web is a service on top of the internet. So the World Wide Web is a way of accessing information on the internet in a graphical form using web browsers. And so it's the equivalent of having visual representations of data that actually exists in a more numerical sense. So the World Wide Web is a service on the internet. And again, if we go back to where this came from, in the 1960s, we started off with the actual building blocks for the internet being created by the Department of Defense. It became part of our kind of national security protocol. And then by the time we get into the 70s through the early 90s, as it sometimes happens, the Department of Defense starts opening it up for academics to come up with ideas and research and concepts. And that's how we came up with things like the World Wide Web. And finally, we get to the 90s, and that means, yes, education has had some time to come up with new and creative ideas. Can we spin them off commercially? And boy, did that work out well for everybody. So the internet basically is a type of communications network that uses what we call IP addressing. Internet protocol is what IP stands for, and essentially it means every device that's connected to the internet has a unique number. And it supports transmit control protocol, internet protocol. You don't have to be a networking expert to understand what this is all about. Transmit control protocol, internet protocol, TCP/IP, is strictly a way of communicating. It's a protocol that tries to connect people repeatedly. So it will make multiple attempts. The idea being, if I'm sending something out over the internet and the address can't be immediately found, TCP/IP will try to continue finding it and will let you know if it found the address or not. So the equivalent is that instead of just shouting out into the air and not knowing if somebody heard you, TCP/IP will let you know if somebody heard you or not. And so again, it was a new building block for us to be able to have the internet. And this also changed into something we call packet switching protocols and client server. Don't worry if you don't understand this stuff right away. Packet switching simply means because we've got a network called the internet that runs everywhere, different speeds, different levels of connectivity. You might have faster internet than I do. Well, what packet switching allows us to do is to break information into small chunks and be able to send it out over the internet where it might take 6 different routes to get where it's going. For example, if I'm sending you an email and the picture that I've got attached to the email gets broken into smaller pieces so it's easier to send. And sometimes the pieces might not be sent in the right sequence. And that means we've got these things called routers that make sure on either end of the communication that things get put back in the right order. So that's how a router works. In the old days, we had what we referred to as circuit switch. Think about old telephone lines. you could talk to one person at a time, and it was a linear connection. You're either connected or you're not. Packet switching enabled people to be connected to multiple locations at the same time because the content was broken up in chunks. So packet switching really was what empowered the internet to be practical. It breaks things down into what we refer to as binary. So if you have text, for example, I don't know how many of you have ever used binary, but binary simply means every bit of information is broken down to a 1 or a 0. So text even is associated with 1s and 0s. And so basically, if you break things down into binary, those binary bits can be shipped out over a network and reassembled. All that I expect you to know from this discussion is that packet switching empowered the modern internet as we know it by enabling us to be able to break content down into small pieces and to reassemble it digitally. And that's what binary is all about. So the protocol itself, again, we talked about TCP/IP. Essentially, Transmit Control Protocol, Internet Protocol, is simply a way for devices connected to the internet to be able to talk to each other, and it's a standard. And so there's 4 layers, and we'll explain how that works. It's sometimes easiest just to put it into a graphic. We've got what we refer to as the network interface layer. Think about this. Right now, I'm on a computer and I'm connected to the internet. I'm connected on the internet right now physically through Wi-Fi. So I've got a wireless connection to an access point in the ceiling. So that's the first layer, the network interface layer, where you actually physically connect to the internet. The internet layer is where you get an address. The host-to-host tells you where you're going. So it's Transmit Control Protocol, Internet Protocol, and the application layer says what are we actually doing. So for example, FTP is File Transfer Protocol, and it enables us to be able to have a service, have an application work on the internet. So the lowest level network, you're physically connecting. Internet layer, you're getting an address. Host to host, you're actually moving that address and connecting to another address. An application, that's the part of the networking that helps us actually do things we want to do on the internet. So to break it down for all this stuff, you can read this for yourself. What it really comes down to is Internet Protocol is kind of the numbering scheme, and the individual IP address is the address our device is connected to. So basically, when we get into the internet, the first type of internet addressing that was commonly used on the web was what we call IP version 4, and it was 32 bits. We went right to version 6. The only thing I expect you to remember from this is a longer number of total numbers and decimals enables more addresses. So we made numbers longer in V6 so that we would not ever run out of IP addresses. And interesting kind of side story, when IPv4 came out and companies were just getting on the internet, the largest owner of IP addresses that bought blocks of these things was Disney, and we were running short on IP addresses. So how does this work? We've got one out of the equation. We've got somebody who's sending an email. We've got our TCP/IP protocol, and it breaks that message into smaller chunks, and they go out of the computer to a router where they're broken into chunks. That could go a multitude of ways across the internet. Let's say I'm emailing my friend in Colorado Springs from here in Loretto. Some of those packets might go through New York, some of them might go through California, some of them might go through Texas, and they're all reassembled at the other end through another router who reassembles all those packets together so that the person can see what I sent to them. So again, routers enable us to chop up and recombine the data. Then we get into the things that make it easy for us to use the internet. The domain name simply means we have associated an IP address with a name. Let's say, for example, I had KentTonkin.com, and I was running that off my local laptop. I was using my laptop as a web server. It would have an associated IP address that would be really tough to remember, but it would be really easy to remember, KentTonkin.com. So that's my domain name. And we have something we call a domain name system, which basically means all the domains, whether it's Nike.com, Francis.edu, Chick-fil-A.com, you pick your domain, that we associate those names with numbers, and then when we enter them or search for them, we don't have to remember the numbers, the name will get associated. That's because we have a domain name service. And a URL, a uniform resource locator, is a specific web address. So if we look at this, for example, the example web address, azimuthinteractive.com, that entire address is a URL. The middle part, azimuthinteractive.com, is the domain name. And so, for example, if you go to a web address, if you go to Nike.com, Nike is the domain name. Then we get into client-server computing. And that meant, for example, because we've got these powerful networks now, our computers can access remote computers. When we talk about, oh, we're storing things in the cloud, it simply means we're storing things someplace other than on our computer, and it helps us connect to central resources. That sounds so fundamental right now, but it was a really new idea in the 60s and 70s, and really didn't come into complete power and industry until then, about the 90s. Then we got the mobile platform. Our small devices, we think of being very powerful. In reality, these devices aren't that powerful on their own. They're powerful because they can connect to remote networks and remote processing. Your smartphone doesn't have that fast of a processor, but because of computer networks, it can access a remote network that is. And so that's what's empowered it. Cloud computing has empowered smartphones and tablets to be portals now into the bigger internet. And so we get into the cloud computing model, it simply means we're doing less on our individual devices and doing more somewhere else. For example, if we've got infrastructure as a service, that means, for example, I'm not going to install routers and switches in my own business. If I've got software as a service, I can access Google Docs or Microsoft 365 online. Platform as a service means that maybe the service platform you're using, your customer relationship management system, isn't installed on your computer. You're accessing it through a web browser. And again, we've got all kinds of access. A public cloud simply means anybody has access to Google. I could create my own private cloud, which Tonkin.com, somebody can get to my web services, but they have to have access, or you can buy these services from people like Microsoft or Google, which makes them hybrid clouds. The great parts are that you can add storage at your whim. The bad parts are that you no longer have physical control sometimes over these kinds of storage. And it can reduce costs, but also there are security considerations. Some people, especially folks from a certain generation, like to have physical control of their storage and infrastructure. So in terms of how this is transformed, I like to quote these stats just to show you how things have changed. If we go back to 2014, smartphones were just hitting. And the most recent stats I have, look at how this goes. We've got, right now, Americans with smartphones, according to 21 stats, we're talking about 85%. Reality, it's probably closer to 90. And we've got fewer folks who are investing into e-readers, but more folks who are using their smartphones for just about everything. Other things that are transforming the way we work, too, we've got more folks who are bringing their own devices and using them for work purposes at this point in time. We've got no need for physical media. People aren't buying DVDs anymore, and more of our devices are connected. As I mentioned in the last couple of chapters, even our cars and the billboards around us are tracking our data all the time. We've got all kinds of mobile devices now. There are lots of other protocols and utility programs out there. The one I would point out to you, if we go to Ping and Tracert, if you ever have had a chance to use Tracert, it's really cool. You can hit a domain and see just how many hops it takes to get from your location to another location. If you are interested in seeing just where your traffic goes over the internet, I highly encourage you to use Tracert. You can look up instructions online for how to use it. So we had the infrastructure that we're using is constantly being maxed out. If we look at what's happening, demand is not slowing down. And we deal with what we refer to as the hourglass architecture. And so there are bottlenecks in the architecture. If we look down, for example, at the lowest level, layer 1, local networks. If you're connected to your office network, things can be moving pretty fast on the network. Things start to slow down when we get out to addressing and we get to layer 2. Once things go out in the internet, the reason that's an hourglass in the middle is essentially we have to restrict the amount of data that can go through. Then we get to middleware services, things like making sure we're being secure, making sure that we are controlling our storage. That can further squeeze us. The applications, however, we get to things like media players, email. There's unlimited demand for that. Why is it called the hourglass model? Because things get pinched in the middle when we run out of bandwidth. That's why we call it the hourglass model. The actual internet architecture itself, sometimes people don't realize this, but it takes a number of hops to get between where you are in your home or office to where you're going out on the internet. I put this slide in mainly because I think it's fascinating. If you have a home network or an office network, for example, you're going out through your internet connection from either your home or your office. You're going out to what we refer to as a regional host. For example, I live in Altoona, Pennsylvania, so my local connector is BreezeLine. So my local internet service provider is BreezeLine. BreezeLine connects through what we refer to as backbone cable out to places like Pittsburgh, the supercomputing center in Pittsburgh, which connects to an actual main leg of the internet. So it's the best analogy I can think of. If we've got a water reservoir, we've got lots of water in one place, and it goes out to homes and businesses by varying sizes of pipe, and that determines how much internet will actually make it to your house. And if everybody turns on their spigot at the same time, the water pressure goes down for everybody because everybody wants the same water at the same time, and that's how we stress out the internet. So the internet backbone itself, I'm not going to spend a lot of time on this other than to say backbone tends to run along major highways or railway routes. It tends to be made out of fiber optics, and we are using satellite for part of it now too. It basically still, for the most part, is cabled infrastructure, although there are wireless and satellite parts to that as well. These go back to main exchange points. We call them gigapops, and they're places like New York City, Pittsburgh, and Philadelphia. And we also call them IXPs. And so IXPs, Internet Exchange Points, essentially are where regional providers end up ultimately connecting. Again, here at St. Francis University, where I'm recording this lecture today, when I post this lecture today, ultimately to hit the main internet, it's probably going to hit the Pittsburgh Supercomputing Center in Pittsburgh because I'm in a regional provider here in Loretto, Pennsylvania, and it will go out through this internet service provider to bigger parts of the internet. And then we get into what we refer to as people who are service providers. We call them Tier 3, and it simply means the people that you are buying your local internet service off of. I don't mean to downplay this. The main point I want you to realize is that your local internet service provider is taking a handoff and going to another provider who's probably going out to a larger part of the internet. So whether you're buying from Verizon, whether you're buying from BreezeLine, whoever your internet service provider is, they're still going back to large shared legs in the network, which a number of providers together support. So we get into what we refer to as campus area networks. It simply means whether you have a business or a school campus, that we tend to have lots of people on the network at any given time, and we tend to have faster connections from regional providers. Well, and then we get into mobile internet access, and we basically are talking about right now, 5G is rolling out quickly across the country. It's pretty interesting. When we look at the ways that our phones connect to the internet, we talk about telephone networks, which are cellular networks, and we talk about wireless, pure wireless, like the idea of Wi-Fi. Cellular has some limitations. You could be standing right in front of a cell tower and have a great signal in the middle of winter because there's no leaves on the trees. When summer comes, you may notice your speeds go down. Why is that? It's because any physical barrier between a cellular tower and your device soaks up some of that signal. And anything with water in it soaks up particular amounts of radiation. And so mobile's limitation is based on what we call line of sight. And so we are seeing more people who are connecting larger speeds to the internet. The important thing to realize is even if I've got a fast connection to my local cellular tower as well, if lots of people are hitting that tower, the actual internet connection it's going to may also get maxed out. Again, it comes down to whatever the bottleneck is, the slowest connection is going to be the fastest speed you will get. Wi-Fi is what we refer to as a standard. It's 802.11, and again, it's a standard. That's why my laptop and my cell phone can both connect to the same Wi-Fi, for example. And it's what we refer to as license-free, low-power connectivity. So you don't have to get a license for it. Anybody can put up an access point, but it's limited power for that reason. And some of the other ones that are emerging, WiMAX and Bluetooth, are similar ideas. Again, Bluetooth is extremely local connectivity, and that's why it works well for things like headsets and microphones. Here's the point to make. Again, you've got all these devices that are connecting to your wireless access point. You may say to yourself, wow, I've got a 100 gigabit connection. Why is my internet so slow? Well, just because you've got a fast connection to your local access point, that does not mean that the internet itself is fast. It's the same reason, for example, if our internet connection goes out at home, but our local Wi-Fi router is still working, we can still connect to the router, but we're not getting any actual internet. And again, the Wi-Fi is just the last part of things. So we've got a number of other approaches that are taking root right now. I encourage you to look these up. In particular, what we've got with Google and Facebook, they are actually using inflatable devices, like literally balloons, floating access points to try to get internet into larger swaths of the world. It's going to be interesting to see in the long run how that kind of connectivity works out. We obviously know that more devices other than computers and smartphones are connected to the internet right now, and we've got more and more of this stuff happening all the time, to the point where our refrigerators are ordering food for us. It's got a lot of great potential because we've got the idea of connected products or connected devices that can do a lot of things and take a lot of headaches away from us. But we also have privacy concerns as well, so it's something to think about. You may also ask, at the end of the day, who ultimately runs this big shop we call the internet? Who is responsible for it? And the answer is, it's hard to come up with a single governing body who is really responsible for everything. ICANN is probably the best potential answer, but really the internet is kind of ruled by agreement. The United States really started most of the standards and controlled the domain name registrations and has subbed out a lot of those to other companies, for example, commercial companies. But ultimately, in terms of legislation affecting the internet, the U.S. government has a disproportionate amount of control, but a lot of it is simply grown-up grassroots to the point where there's not really a clear line who is the ultimate controller of the internet. Now, the Internet Corporation for Assigned Names and Numbers, ICANN, who ultimately is kind of a collaborative with all the countries of the world who are part of this discussion, makes a lot of the decisions about, are we going to have, for example, a new tag? Years ago, for example, we had .com and .net, and we started adding on .tv and .xxx, for example. They make those kinds of decisions, but they're largely based on consensus. So it's really tough to say who controls the internet. If you had to take it down to one agency, I would say it would be ICANN. And then we get into who actually controls the internet. Well, we enjoy a lot more freedom on the internet in the United States than, say, people do in China. China censors its own connection. And this, again, it's a kind of still a no man's land. When I say that, I don't mean to scare you. Different countries have different standards for who can control the web and how long content can exist. And it's really a patchwork quilt of regulations. Let me give you an example. Here in the United States, let's suppose you were convicted of a felony. That could remain on Google the rest of your life. So somebody could look you up and see, well, Tonkin had been convicted of a felony at some point in time. I have not, but it could be out there. There are laws in Europe called the right to be forgotten, where essentially the European Union sued Google and said after somebody served their time for a crime, you should no longer be able to find that on your search engine. And Google had to comply. And the Chinese government runs things in a different way than the United States does, which is a big reason why Google pulled out of China. And so it's a real tough situation to determine who we want to do business with, who we want to maintain presences with, and how we actually run the internet. So it's not much of an answer other than to say how much freedom you have on the net really kind of depends on where you're at and which government you are under. So what are some of the limitations? Well, right now, a lot of our internet is operating on old copper infrastructure that's wearing out. We don't have enough fiber optics to keep up with demand. It's better than it used to be, though, I have to say. Back in the old days, back in the 90s and early 2000s, I was working here on the East Coast, and I loved getting on the internet first thing in the morning because right around noon, everything would slow down. And the reason being is because the West Coast was waking up, and everybody was on the internet slowing it down. And so even as recently as the early 2000s, we really had problems with infrastructure. And so companies are upgrading this stuff. We're trying to go all fiber, but it takes time and it costs money. When you talk about the last mile is where the internet actually connects to your house. And the first mile is the actual big infrastructure that powers larger parts of the internet. There's more money upgrading the first mile in big cities than there is the last mile out here in rural America. And again, it's another reason why rural communities tend to suffer. And a big part of it is because there's just not a cost model here for it. So again, fiber optics is the most ideal way to do transmission of this stuff, simply because it operates at the speed of light and it's got nearly limitless capability to carry data, and it also does not physically degrade it over time in the same way that copper does. Think about this. If you're running any kind of network over copper cable as an electrical conductor, over time, if you run electricity through a conductor, it loses its conductivity, it wears out in time. And that's why we're going more for fiber optics. More expensive, but higher capacity. We talked about the web. The web really only emerged in the late 80s, and the idea being that we had a way to graphically search for data on the internet. And again, the idea of being able to visibly see representations of data on the internet, that's a service called the web. And you still had to know IP addresses. You still had to know where you were going, because web browsing really didn't emerge until about 1993, the Mosaic web browser, which is now Firefox. It was the first graphical user interface to really come up with a standard usable interface for everybody that would run on any platform. So we had basic web browsers in 89 to 91, but really the emergence of a real mature web browser came out in 93. It was commercialized in 94, and then Microsoft got on board with Internet Explorer in 95. So remember, the web is a service on the internet. Hypertext changed everything. The idea of actual links that you could click on visibly and go to other places on the internet. That was something that emerged during this time period. And again, Hypertext Transfer Protocol, HTTP, and you have an entire URL. You know, of course, that the megacorp.com is the domain, but that URL and being able to click on a hyperlink through hypertext was something that emerged during this period as well. And in terms of the languages used, HTML essentially is the language we use to write and create code and make web pages. It's kind of becoming a lost art, because most of the time these days when we're creating web pages, if you're using Wix or GoDaddy, a lot of these services are just point and click right now. If you're using e-commerce platforms such as Shopify, not a lot of people are really worrying about learning code anymore. Now, people who do large-scale development are, but a lot of people are not. And again, if we look at hypertext markup language, HTML, and XML, essentially is a way of speeding up. I won't go into the finer points other than to say XML is a way to speed up the transmission of data on platforms like smartphones, for example, by giving people a way to know what data they're going to reach before they hit it. I know that's a very nondescript statement I made, but XML basically allows apps on smartphones to know what data they should be pulling from more quickly. So if you remember out of this discussion, HTML was the language used for creating web pages. You've probably hit enough for this particular course. And so we had different goals designed for these. XML was describing and carrying data. HTML was displaying it. And so again, XML teaches devices what data they have coming toward them. And then we have web servers. A web server can be hardware or software. It simply is a web server is what runs a web page. A web page has to reside somewhere, and it's on a computer. And so a web server, the most popular one in the country is still Apache because it's free. But a web server can be a hardware box, or it can be a software design. So we've got things called virtual machines these days, and you could have one machine running a number of servers on it. And so a web server can be listed as either physical hardware or software. And you got servers that run specific aspects of e-commerce, such as databases. And then you got web clients. And any device we are using to access the web is a client. Whether it's your smartphone or your laptop, it's a client. Browsers, again, have changed the game. We see that, for example, Google Chrome is still the dominant player for desktops, but it's got a nice share of the market for the mobile as well. I know a lot of us, for example, I'm a big Google fan. I still tend to use Chrome on my iPhone as well, but a lot of folks just do default to the built-in Safari browser. Now, here's what is interesting. With the AI wars, Google has been losing a little bit of market share because of Bing and Microsoft Edge being AI equipped. But there's a lot of folks who are still resisting that simply because of an anti-Microsoft bias as well. So in terms of some of the features of the web, these are all things we can do, and we are still at the tail end of Web 2.0, and the idea that we are in an interactive period because of things like social media, because of things like video, things like Zoom. We are going to be hitting a massive explosion of interaction because of AI and new ways of using the web based on what's happening with Web 3.0 right now. All of these are things you're very familiar with. Email is still the biggest use of the internet in terms of applications, and I think the recent stats are about 80% of all email is spam, but we still use it because it's cheap and it's largely free. And we're seeing, for example, services such as video are becoming more possible because of investment in the internet. Here's a really important thing to realize. When we are using search engines, I happen to use Google as my default. Some folks are using AI-powered Bing or whatever your search engine of choice is. Search engines are not truly looking at the internet. Search engines look at an index of the internet based on whatever company is operating. So when you search Google, you're not searching the entire internet. You're searching Google's index of the internet, which is why it's so fast, number one, and number two, why some results don't come up. Google was the first one to do an indexing of the internet, and I would love it if you would read this more in depth on your own, but basically Google has things that essentially are web crawlers that search the known internet for valuable data and index it based on things like keywords, based on images, based on sites that it's linked to. And essentially, they index and document everything that's on the net. That's their mission statement, is to make all information on the internet available. The takeaway point to this, although Google did something nobody else had done when they created it, Google is not everything on the internet. Google, when you do a Google search, use their search engine, you are going through an index of everything that they have documented on the web. So what's so special about it? They were the first search engine to really cross-connect, to say, well, if this site is linked to this site, there may be valuable here. There may be value here, I should say. And I think why Google is such an important consideration is most people at this point in time are not going past page 2 of a search. It's really important to understand things like search engine optimization. So your company ends up on the first page of Google. And we're also going to be getting into how Google makes its money off advertising in some of the coming chapters as well. Even in 2024 and beyond, with all these awesome services that Google gives us, their main source of revenue is still advertising. Again, streaming media and downloading have killed the physical media industry. And when we think about it, when Netflix first came out, Netflix did not stream content. They allowed you to browse their database of DVDs and they mailed them to you. And why was that? Because most people didn't have a high-speed internet connection that would support watching whole movies. And now we all do. And so that's the reason why we are no longer buying physical media. Although the revenue models behind these services are coming into question. As I mentioned in an earlier chapter, Amazon just announced for their Prime Video, they're going to be reinserting ads into all of their videos. And so, yeah, we've got a whole different landscape that looks a little more familiar than not. Cisco predicted that basically by the time we hit 2023, that about 8 out of every 10 packets on the internet were going to be downloads and videos. So that was their prediction. And in terms of the most recent information I've been able to get, Netflix, one company right now, and again, this is a prediction. This is 2023. I cannot verify this other than from our good folks at Statista. Netflix right now is responsible for about 15% of all internet traffic. And if you look at what's driving traffic, Yeah, it's all video, it's all content, it's all social media. And again, the number one use of our smartphones is for entertainment. Netflix is still the king in terms of streaming media, but Prime is running neck and neck. If we look, again, these were predictions. So by the time we get into 2024, I'll be able to tell you if Prime is caught up with Netflix or not. But yeah, we've got, for example, a lot of predictions, a lot of guesstimates, and we're also going to see a lot of consolidation in this industry. In other words, companies coming together. So where we are with Web 2.0. The interactive internet has enabled us to create services that support interaction and ways of interacting with each other and also selling each other stuff. And that really wasn't part of the first part of the internet, or the first part of the web, rather, in the late 90s. If you had gone to a web page in the late 90s, it would have been largely flat, manually updated content. And now we're seeing more interactive types of content. And this is where we're at. Web 3, that is in the process of emerging right now. I think that we can't even get our heads around. In the same way that I don't think any of us truly saw what was coming with the AI revolution when things like ChatGPT and DALL-E and all this really iterative AI started hitting. Now we're essentially going to be entering an era where we are going to be able to have AI create content that we want. Think about having AI create movies for you, or stories for you, or products for you. And I can't even imagine the technology infrastructure this is going to require and the sheer processing that it's going to require. It's both inspiring and terrifying when you think about it too much. And I'm having a hard time putting it into words because I don't have my head completely around it either. And part of this is going to also go into more things like experiencing the internet in a more physiological sense, between virtual reality, the idea of wearing headsets and even sensory suits to experience travel or other kinds of sensation on the internet. We're already in the augmented reality era. The best example I can think of that is Pokemon Go. We're seeing now people are using more smartphones. Google's made several attempts with Google Glasses to be able to have people have an augmented reality experience. But I think we are going to be seeing more of that emerge into more of a mixed reality. It's just a matter of time and a matter of a generation who is willing to adopt it. We're also in the era of intelligent digital assistants, and AI is going to change the game on this as well. Where a lot of people don't make frequent use of Siri, for example, on their iPhones, Alexa has become a common word in most homes in America, and people who are using low-cost devices. Why is Amazon selling these so cheaply? Because it makes it easier for people to buy more stuff from them and to gather data about them. Even when we get into the idea of smart televisions, they're becoming closer and closer to digital assistants and the ways that we interact with them. To that end, this is something that actually debuted about 2 years ago. This is an actual AI anchor for a state-run news service in China. And so the news is reported now through an avatar who looks very, very human. And we're already starting to see some of this emerge in our entertainment these days. There's a whole level of ethics to explore beside the technology in this regard. So what are the implications? The implications are just how much are we going to interact? Just how real are they going to feel? If we're getting into, for example, I was doing some research on a company out of California that's having an AI assistant interview someone so that they can create an avatar of them that will interact with their children after they've died. You can literally go and talk to somebody who has passed and get answers from them in the way they would have answered those questions. And so we're entering yet another era where the technology is outpacing our ability to understand it. And from an ethical standpoint regarding e-commerce, at what level is this going to affect the stuff we buy and how we interact? Then we get to our home stretch, and it comes down to the idea that the mobile revolution is taking over everything. I actually ask my students to report their screen time every semester. I think the highest screen time report I've gotten was 15 hours a day. So we're hooked to our phones. One of the end results is, too, because we're using apps so much, we're seeing a little less reliance on search engines. On Google, on our phones, what do I need Google for when I can buy what I'm looking for off Amazon or off of Nike, for example? And so we're seeing more apps that are serving as gateways into the internet. And that's a good place for us to stop in terms of our exploration, where we started in the 60s with a network that was designed to survive nuclear attack, and ending in 2024 with the emergence of AI and the next level of mobile. Thanks so much for your time and attention. I look forward to speaking with you.